All right, guys, so what we're going to be looking at here is the second day of learning to use the chain rule. Okay, yesterday, or in the previous lecture, whenever it was, what we looked at was polynomials and what happens when we have a composite function involving polynomials, as well as kind of where the chain rule comes from. So if you haven't watched that video yet, I would recommend that you go and do that before you watch this one, or if you were here during class, whatever. Just make sure that you understand the basics of the chain rule, because we're not going to go over a whole lot of those again. Okay? What we're going to be talking about here on the second day of the chain rule specifically are trigonometric functions. Now, a trigonometric function is one that involves sine, cosine, tangent, secant, cosecant, or cotangent. We talked about those in the previous unit where we talked about how to take the derivative of all of those things. And we did discuss what makes them different as far as how they're different than a polynomial function. The one thing that everybody needs to focus on when we talk about the difference between these is if I write down sine or cosine or tangent, and I'm not taking the sine or cosine or tangent of something, that is nothing, okay? We have to have the sine of something. Usually we say the sine of x, or the cosine of x, or the tangent of m, or something like that. There has to be the sine or the cosine or the tangent of something. And that's really important to understand that when we take the trigonometric functions like these, we're asking about all of these x's or m's or whatever. Those are angles. Okay, so sine of an angle or cosine of an angle is always asking you what is the ratio between two sides of a right triangle. We're not going to get into that much. We'll deal with trigonometry another time. But knowing that you have to take the sine or cosine or tangent of something is very important when we're using the chain rule, and it's where people really get confused. Okay? Now, the other thing that I do want to talk about is, and that's not what that is supposed to, that when we use the chain rule, remember, the way that the chain rule works is when we take the derivative of a composite function, we go the derivative of the outside function, and then we leave the inside function alone, then we multiply that by the derivative of the inside, okay? A couple of things that are different with trig functions as well is when we see the sine squared of x, it looks like the sine is being squared. In reality, what is happening is the sine of x is all being squared. So it's like there's parentheses around the sine of x. Then whatever this exponent is right here, that is happening to the trig function. So if I had like tangent to the fourth of x, what that's really saying is I've got tangent of x being raised to the fourth power. So, and that's really important, again, to understand that that is a composite function, kind of like what we were talking about previously, okay? So, if I wanted to take the derivative, for example, and I know it's got the derivative here, if I wanted to take the derivative of the sine squared of x, what that is really saying is, and this is where this comes from, that's saying I've got the sine of x being squared. So if I want to take the derivative of that, I've got a function, my sine of x is on the inside, so I would bring the 2 down, and technically that would be sine of x to the first power, and then I would multiply that by the derivative of what is inside of the parentheses, so that would be cosine of x. So realizing that the exponent right next to the sine, cosine, or tangent is really applying to the entire function makes it so that when we take the derivative of a trig function, it's basically the same thing that we were doing yesterday. So here's another example. Let's say I had cosine to the fourth of x. Now remember, what this is really honestly saying, what this is really saying is I want to take the derivative of the cosine of x to the fourth power. So if I'm going to take that derivative, I'd bring the 4 down. I'd leave the cosine part alone, because that's the function that's on the inside, to the third power, and then I would multiply that by the derivative of the cosine of x, which in this case is negative sine of x. And then generally on the AP test, they'll have you multiply the constant numbers together. So like 4 times, this is technically negative 1, so that's like negative 4 cosine of x to the third power multiplied by the sine of x. That's how you'd see it on like a multiple choice question if you were looking at the AP exam. So that's what that derivative would be. And as long as we understand how to deal with these exponents when it comes to that type of function, usually they're not too bad and we don't worry about them too much. Now, where this gets a little bit more complicated is when x, or whatever it is, when we have a composite function where the sine or cosine or tangent is the outside function. So you'll notice like here, I've got the sine of x to the fourth. notice that the x is the only thing that is being raised to the fourth power. So what we really have here is a composite function. Originally, we had this, we had the sine of x was our original function. And then what happened was we had a second function that was x to the fourth. And I took x to the fourth and I replaced that x in the sine of x with sine of x to the fourth. So our composite function in this case, the sine function, is the function that is on the outside of it's the outside function. It's like our f of x, if you will. So the way that we take the derivative is we realize the sine, it's almost like that's before when we were looking at polynomial functions. It's what the entire parentheses was being raised to. This is different now because this is sine of x to the fourth. So if I was to take the derivative of that, I'd realize that the sine is our outside function. So the derivative of sine is cosine of x, but I leave my inside function alone. So this is like our x, but it's x to the fourth. I leave it alone. I don't touch it. Then I multiply that by the derivative of the inside. Our inside function is x to the fourth, so that's like 4x to the third. If we used our process that we talked about before, I'm just going to go through this real quickly, we would let our u equal x to the fourth, which would mean that I would have y is equal to the sine of u. I take the derivative of that. I get dy du is equal to cosine of u. Then I would get du dx is equal to 4x to the third. Again, this isn't what you have to do, but I think it helps us see a little bit better what is going on. So if I get dy dx, multiply that, or dy du, multiply that by du dx, I would get cosine of u times 4x to the third, and then I just replace the u with what we had originally, which is x to the fourth. So I'd have cosine of x to the fourth multiplied by 4x to the third. And that would be my dy dx. So not that big of a deal for that. Okay, so that's where it comes from. That's how we take the derivative of those. We just have to be careful when we look at them, because a lot of people, when they see, like, for example, when I see a problem like this one, notice, and this makes this more complicated, this is really cosine of 3x minus 1 all being squared. And we didn't really deal with these very much yesterday or the day whenever you looked at this previously, where we have multiple composite functions. But really all we have to do is take these one step at a time and we'll be totally fine. So I've got the entire thing being squared. That's like my outside function. So I bring the 2 down, and everything on the inside stays the same to the first power. So I brought the 2 down. It's just like a polynomial. So I took the derivative of that. Now I have to take the derivative of the cosine of 3x minus 1. Well, that's what we're talking about now. I got to take the derivative of the cosine of 3x minus 1, which that's another composite function. So I'm going to take the derivative of cosine, which is negative sine, but because it's not the cosine of x, I have to leave the inside part alone, just like that. Then I'm going to multiply that by the derivative of what is on the inside. So I multiply that by 3. Now, one way to kind of keep track, in the way that I like to look at it anyway, is if I've got these multiple composite functions where it's like f of g of h of x is kind of the way you could look at this, is I like to cross off what I took the derivative of initially. So I took the derivative of the 2. This part all stayed the same. Then I took the derivative of the cosine. This all stayed the same, so that's why this was negative sine of 3x minus 1. Then I took the derivative of 3x minus 1, which is 3, and everything's crossed off, which means I took the derivative of everything that exists, multiplying them together one at a time. Again, hopefully that kind of makes sense. These problems are usually where the chain rule catches a lot of people. The chain rule still applies when we're multiplying two things together. So if I wanted to find the derivative of these two things multiplying, I would say, okay, here's my first function, here's my second function, and I'm going to use the product rule. And when it comes time to use the chain rule for our first function or second function, to take the derivative of those, that's when we'll do it. So the product rule says first function, so that's my sine of 2x, multiplied by the derivative of the second function. In order to take the derivative of that, I bring the 4 down. I've got 3x plus 2 to the third power. And then I need to multiply by the derivative of the inside part. Again, I am using the chain rule to take this derivative, which is where that came from right there. But what we have to realize is this is a product rule. This is my first term times the derivative of the second term. Plus, now I write my second term down, 3x plus 2 to the fourth power. That's my second term right there. Multiplied by the derivative of the first. The derivative of the sine of 2x is the cosine of 2x multiplied by 2. So that's the derivative of the first term right there. So we have to realize when we're using like the quotient rule or the product rule especially, that those things, it's not necessarily that they come first, but we have to realize that overall what's happening is those two functions are multiplying together. So I have to take the derivative of two things multiplying together, I have to use the product rule, and then the chain rule just comes into play while we're using the product rule, okay? So hopefully that kind of makes sense. Make sure that every time you do these, when we take the derivative of anything, that we take the derivative one step at a time. It's very important that we don't go skipping steps when we take the derivative, because they'll know that you're doing that on the AP test. It's a really easy way to catch you making mistakes. If you have any questions about how to take the derivative of trig functions or how the chain rule works in general, please let me know.